A fuel pressure sensor measures the pressure of fuel being delivered to the engine's injectors. It converts this pressure into an electrical signal that's sent to the engine control module. A fuel pressure sensor typically uses a piezoelectric or strain gauge mechanism to measure fuel pressure. This mechanism converts pressure into an electrical signal that reports the pressure in pounds per square inch, or PSI, to the engine control module, or ECM. Normal fuel pressure ranges from 30 to 60 psi at idle and 45 to 80 psi under load, depending on the vehicle. When the sensor is bad and provides inaccurate readings, the ECM misadjusts fuel delivery, leading to performance issues. Poor engine performance is the first major symptom of a bad fuel pressure sensor. This includes engine hesitation during acceleration, reduced overall acceleration power, frequent misfires, and decreased fuel efficiency. If the sensor over-reports fuel pressure, the engine control module thinks there's more fuel than there actually is, causing the engine to run lean with too much air relative to fuel. Conversely, if the sensor underreports pressure, the module assumes there's less fuel, leading to a rich condition with too much fuel and not enough air. These fuel-air imbalances can trigger the check engine light on the dashboard and generate specific OBD2 diagnostic codes, such as P0190 through P0193, indicating fuel pressure sensor circuit issues. Difficulty starting, especially in cold weather or after idling, is a key symptom. This stems from low pressure signals preventing proper priming of the engine. A failing sensor might cause the ECM to shut off fuel pumps prematurely, preventing the engine from starting easily. Common causes of fuel pressure sensor failure include corrosion from contaminated fuel, electrical faults such as wiring harness issues, and wear from high mileage. To diagnose a bad sensor, use tools like a multimeter or scan tool to test the sensor output. Normal voltage output ranges from 0.5 to 4.5 volts. Always check the voltage outputs first. The sensor is a key component in the fuel system, positioned between the fuel pump and injector. A real-world example comes from the 2018-2022 Ford F-150 trucks. Faulty fuel pressure sensors were responsible for hard starts in 12% of cold start failures. Owners experienced repeated cranking due to sensor drift in the direct injection systems. While replacement costs averaged $200 to $300, many successfully performed DIY fixes using OBD2 readers. The automotive industry is undergoing a major transformation. Electric vehicle adoption is rising rapidly, projected to reach 40% of global sales by 2030, leading to fuel pressure sensor obsolescence in internal combustion engine vehicles. However, the aftermarket sensor replacement market continues to grow at 5% annually, driven by aging vehicle fleets that still require maintenance. Future sensors will incorporate artificial intelligence for predictive diagnostics and self-diagnosis, potentially eliminating mechanical sensors entirely in favor of virtual simulations.